Hey everyone, and welcome to The Explainer. Today we're going to jump in a time machine and head back to the early days of the World Wide Web. See, it wasn't always this dynamic universe we carry around in our pockets. It started out as something, well, a lot simpler. We're going to peel back the layers and look at the seriously clever code and brilliant ideas that fixed the internet's first big problems, turning it from a clunky, static system into the powerhouse we use every single day. So, that really brings us to the big question, right? How in the world did we get from there to here? How did we go from these pages of just plain, boring text to this vibrant, interactive experience that works just as well on a giant monitor as it does on a tiny phone screen? Well, the answer isn't one single thing. It's really a story about a series of problems and the super clever solutions that came along at just the right moment to fix a major headache and push the whole web forward.
All right, so here's how we're going to break it down. First, we'll look at how the web got its sense of style. Then we'll see how developers managed to squeeze the entire internet into our pockets. After that, we'll uncover the magic that finally made web pages come alive. And to wrap it all up, we'll take a peek at the engine under the hood that makes it all possible. Okay, our first stop, the early to mid-1990s. And the problem was pretty obvious. The web was functional, sure, but man, was it bland. You see, HTML, the language of the web, was built to describe content. This is a headline, that's a paragraph. But people wanted their pages to look good. This led to this really messy situation where style tags were jammed right into the HTML itself. Now imagine you have a website with thousands of pages. If you wanted to change the color of your headlines, you'd have to manually open every single file and change that tag. It was a total nightmare, long, expensive, and you're almost guaranteed to make a mistake.
The solution was an idea that was as simple as it was powerful. Let's separate things. Let's let HTML do what it's great at, describing the structure, basically the nouns of the page, and then let's invent a totally new language to handle how it looks, the adjectives. This new language would describe the colors, the fonts, the layout, all the presentation stuff. This single idea, this separation, is literally the bedrock of all modern web design.
And that new language, well, that was cascading style sheets, or as we all know it, CSS. It was created by the World Wide Web Consortium, and its whole purpose was to pull all of that style info, the colors, the fonts, the spacing, out of the HTML and put it into its own separate file called a style sheet. This was a total game changer. Seriously, instead of editing thousands of pages one by one, you could now edit one single file and change the look of your entire website in an instant.
And you can see just how efficient this is. Look at this little bit of code here. With just these 3 simple rules, you can define the style for an entire website. The first line, body, background color, light blue. Boom. The background for every single page is now light blue. The second line makes all your main headings white and centered. The third line sets the font for all your paragraphs. Change one value in this one file, and thousands of pages update immediately. That's the power we're talking about. So, what's the cascading part all about? Well, think of it like a waterfall of rules. Styles cascade down in order of priority. The most general rules are in that external file for the whole site, but you can override them with styles inside a specific HTML page. And you can get even more specific with an inline style on just one single element. This system gives developers this incredible fine-grained control to set global rules, but also make tiny exceptions wherever they need to. Okay, so CSS solved the style problem, but right around the corner was a brand new challenge, the mobile phone. And we're not talking about your latest smartphone here. We're talking late 90s, early 2000s tech. These things had tiny black and white screens, barely any memory, and connected over wireless networks that were, well, painfully slow. The normal web, built for big desktop screens with fast connections, was completely useless on these things. This was the massive question everyone in tech was asking at the time. How do you get useful information onto these new little devices? Standard HTML pages were way too big, they required too much data back and forth, and even if you could load one, it would just be a jumbled mess on that tiny screen. They needed a completely new approach, something built from the ground up for the limits of the wireless world. The answer came from a whole new ecosystem called WAP, the Wireless Application Protocol.
And at its heart was a new language, WML, or Wireless Markup Language, created by mobile giants like Nokia and Motorola. The easiest way to think of it is as a super lightweight, stripped-down cousin of HTML, designed specifically to be small and efficient. WML's real genius was its deck and card model. This is super clever. Imagine a physical deck of index cards. The entire stack of cards is the deck. That's the whole WML file that gets downloaded to the phone in one small chunk. Each individual index card is a card, and it represents just one screen's worth of information. So you're not constantly going back to the internet to fetch new pages. You're just flipping through these cards that you already have on your phone. And this is what that looked like in the code. A link, like the one you see here, didn't tell the phone to go out to the internet and get a new page. That little hash symbol there? That's the key. It told the phone's browser, hey, don't go back to the internet, just flip to the card named 2 that you already have in the deck. This made things feel super fast and responsive, even when your connection was ridiculously slow.
All right, so now we've got pages that look good, and we even have pages that work on our tiny phones. But there was still one huge problem. Web pages were fundamentally static. They were basically just digital documents. If you wanted to do anything interactive, fill out a form, see a live update, even do a simple calculation, the browser had to stop, send a request all the way back to the server, and then the server would build and send a completely new page back. Every single click meant a full page reload. It felt slow, it felt clunky, it felt like reading a document, not using an app.
Now, the solution here wasn't some brand new language. It was a new name for a team of technologies that already existed, Dynamic HTML, or DHTML. And you really got to get this. DHTML isn't one thing. It's a team-up. It's the idea of using HTML for the content, CSS for the style, and a scripting language, which was almost always JavaScript, to change that content and style in real time, right there in the user's browser without ever having to talk to the server again. This was the key to making pages feel alive.
So let's see how this team works together, using a classic example. First, you've got the HTML. It's just building a simple form. 2 boxes to type numbers into, a box to show the result, and a button. But look at that last part. OnClick equals sum function. That's the trigger. It's basically telling the browser, hey, when someone clicks this button, go run the script named sum.
And here's the action hero of the team, the JavaScript. When you click that button, this script just zips into action. It grabs the value from the first box, grabs the value from the second box, adds them up, and bam, it puts the result right into that third box. All of this happens instantly inside your browser. The page itself changes without a slow, clunky reload. That was the magic of DHTML.
So far, we've been looking at the code that makes pages look and act a certain way. But now let's take a big step back and look at the fundamental system that lets any of this happen at all. How does your computer, the client, actually talk to a website's computer, the server, when it could be halfway across the world? Well, this whole conversation is built on a really simple but really powerful model. At its heart, the entire web, the whole thing, runs on what's called a client-server model. It just splits the work between 2 players. On one side, you've got the client. That's you, or more specifically, your web browser. The client is the requester. You're the one asking for stuff. On the other side is the server. That's a powerful computer sitting in a data center somewhere that holds all the website's files. The server is the provider. Its only job is to listen for your requests and then send you the stuff you asked for. So this whole back and forth, this conversation, boils down to a simple 3-step dance. First, your browser, the client, sends out a request for a web page. Second, that request zips across the internet to find the right server. And third, the server gets the request, finds the file you wanted, and sends it right back to you. That simple request and response cycle is the engine that drives everything you do online. So, when you look back, it's pretty amazing how these clever tools, CSS, WML, DHTML, solved these huge growing pains for the early web. They built the foundation for everything we have today. But that gets you thinking, right? The web never ever stops evolving. So if those were the big problems back then, What are the big challenges, the growing pains that developers are battling right now? How do we build for a world of artificial intelligence, guarantee security against incredibly sophisticated threats, and deliver instant performance to billions of users all over the globe? The problems have definitely changed, but that same spirit of innovation that built the early web is what's still driving it forward today.